Working with algorithms is fundamental to getting the most out of Grasshopper. But what exactly is an algorithm? Simply put, an algorithm is a step-by-step procedure. In math and computer science, algorithms are used for calculations or problem solving. But the concept can be seen elsewhere too, in places like recipes, games, or even instructions for assembling things like furniture. Algorithms are defined lists of successive, but not necessarily sequential steps, each with well-defined instructions. Since they're sort of like lists, algorithms have beginnings and ends. In their beginning states, algorithms take data in the form of variable inputs. Inputs are processed through the algorithm's steps and transformed into some kind of information or output, which is given in the end state. Algorithms exist in many different forms, from written instructions to flowcharts to formal computer language to electrical circuits, just to name a few. Let's take a look at this example of a flowchart. Here, our input is temperature data. Maybe it's a reading from a thermometer or a temperature sensor, or maybe from somebody just typing in the temperature that they read. The process is to compare that reading to a standard value, so in this case, 32 degrees. Then the output is information about whether the temperature is above or below freezing. Later on, we'll get into more details about how exactly to set up algorithms inside of Grasshopper. In addition to algorithms, something we'll talk a lot about while working with Grasshopper is data. So what exactly is data? Well, when we talk about data, we're talking about plain, unorganized facts. Data can be qualitative, relating to observable things like color, shape, or size, or it can be quantitative for things like length, volume, or area. Data and information are often used interchangeably, but there are important differences between the two. Data are raw facts with no context or organization, and data becomes information when it is processed, structured, or contextualized so that it becomes useful and meaningful. Now, inside of Grasshopper, we can get data from a few different places. One of those is from geometry that we model in Rhino. So this could be something like the location of the center point of a circle, the length of a line, the curvature of a surface at a given point, just to name a few. We could also have locally defined data, which is essentially numbers, names, or other things that are manually entered by you, the user. You'll often hear the term data flow when working in Grasshopper. Now this makes sense because the interface is set up so that data flows into and out of the component parts of an algorithm. We'll cover working with data in more detail in later videos, but for now,